Hello, my name is Darren Thomas, and I'm the Director of Educational Research Techniques. In this video, we're going to be taking a look at, it's not really a different differentiation rule, but we just kind of called it that, and that is dealing with derivatives that involve sine and cosine. So let's go ahead and get started. So the general rule when you're talking about derivatives for sine and cosine, and again, you can kind of work through the proof on your own, but generally when you have derivative of d of x, and you have sine here. This is just another notation for making derivatives. It's going to become cosine x, like so. And when you have the derivative of d of x like this, and you're dealing with cosine, whoops, there we go, fix that. Cosine x, it becomes negative sine x. That's kind of how it works out. And so this is just the rule. And so what I want to do now is I just want to kind of give you an example of this so that you can see it in action. We'll do two examples. So our first example is going to be, you got f of x, and it's going to be 5x to the third power, excuse me, times sine x. All right, so now we need to figure out what is going to be the derivative of f of x. And so if you look at our example here, we're going to have to use the product rule. We've talked about this in the past. This is going to take the product rule. And so what we do here is first we find the derivative for 5x to the third, excuse me, and that's going to be 15x squared. And then you're going to multiply that by, just leave the second guy alone here, sine x. And then after you do that, you take the original guy right here, 5x to the third. You don't change him at all. Just put him like this. And then you're going to multiply him by the derivative of sine x, which we know that the derivative of sine x is cosine x. And so that's essentially your answer right there. Again, it's not that deep, not that complicated, but this is what we need to do. So maybe if I put this guy down here, you can see that this is the answer. Let me just write this, 5x equals, that's our prime, 5 prime. Okay, so this is our answer. Very simple, not that complicated, but again, you just have to know what the rules are. The proof for this is kind of complicated, so like I've already mentioned, you can look at that on your own time. Now let's do one more example that's a little bit more complicated so that you can see how this can work in action. So this time we got f of x over here in the top equals cotangent x. And so of course we want to find the derivative of cotangent x. So the first thing we got to do here is, generally when you're working with trigonometry things, you always want to think of things in terms of cosine and sine. So cotangent, another way of thinking about this is of course going to be cosine x over sine x. Okay, and so now that we have a fraction here, we're thinking quotient rule now. That should be something that's coming up in your mind, quotient rule. And so what we need to do now is that when we're dealing with quotient rule, you take the derivative of the top number, the numerator, multiply it by the denominator unchanged, and you subtract that from the numerator multiplied by the derivative of the denominator. And all that is going to be over the denominator squared. Again, we've done this before, and let me just kind of write this out for you. So I need to first take the derivative of my numerator here. And so my derivative is going of cosine, like we've already talked about, is negative sine x. That's what we're going to do right there. And so this is going to be multiplied by the denominator unchanged. So multiply by sine x. Now I'm going to subtract that from the original value of the numerator, which is cosine x. And then we're going to multiply that by the derivative of the denominator, which for us is going to be cosine x. And then all this is going to be over the denominator squared. So in our case, I'm going to make this sine squared x. So that is the first part. And we're just about done here. I mean, we can simplify it. And so as we simplify, we'll see more patterns here. So now I have negative, if I simplify this, I'll have negative sine squared x like so, minus cosine squared x like that, over, let's see here, sine squared x like so, all right? Now for the top, we can simplify this to minus 1. Let me see if I can make this clear for you, because if you know your trig identities, cosine squared x plus sine squared x equals 1. So negative sine squared x minus cosine squared x is going to equal negative 1. And so that is how we get this negative 1 for the top, for the numerator, excuse me. All right, you need to know your trig identities. Again, that's just raw memorization. There's really no secret technique to that. Now, this guy right here also, so let me slow down here. This guy right here is a trig identity. Normally, it's a sine x squared or sine squared x plus cosine squared x is going to be positive 1, but we simply have two negatives is going to be negative 1. So that's why the numerator now is negative 1. But this guy right here is also a trig identity. If you can see here, this is for cosecant. So when you have 1 over sine x, that's going to be cosecant. So when you have negative 1 over sine squared x is going to be negative cosecant squared. So in other words, this is going to be equal to negative CSC squared, and then we're going to have our guy in x here. So this is our final answer right here, this guy, if you want to simplify. And so you can see how you have to pull all these different tools that we've been learning and using in the past in order to get the most compact, succinct answer. And again, it just takes practice in knowing when to see these different clues and cues to know what is the next most appropriate step. So let me go back and review what we talked about and conclude the video. So in this video, we talked about how to deal with derivatives involving sine and cosine. So simply, if you're looking for the derivative of sine, it is cosine. If you're looking for the derivative of cosine, it is negative sine. And so on this screen right here, we did a simple problem involving using sine in an actual derivative. This, of course, we applied the product rule and then we worked everything out and we got our answer right here, in case you forgot, this guy right here. And then we continue this by looking at a slightly more complicated example on the next screen. So here we were looking for the derivative of cotangent x. First of all, we looked at cotangent x in terms of cosine and sine. We used the quotient rule, and then after that, we applied our knowledge of trig identities to get our most simplified form over here, cosecant squared x. That's what we got. So I want to thank you for watching. My name is Darren Thomas. I am the Director of Educational Research Techniques. Take care.